Lesson 6, Interpreting Nonlinear Graphs. As you can see from the technical drawing below, we've done some graphing before of some things. Now we're going to graph all the things. The learning intention for today. Students will understand the role of the gradient in a distance time graph specifically, and you will be able to use nonlinear graphs to explain real-world scenarios modeled by those graphs. As success criteria, you can interpret nonlinear graphs used to model situations using two variables. I apologize in advance. So nonlinear graphs, well, what are they? Not all graphs are straight lines, in case you hadn't noticed that. And any graph that is not a straight line is called a nonlinear graph. Kinda obvious, but it bears saying. The first type of graph that we're going to look at is the distance time graph, which is a really important graph, very common if you ever do physics. It's one of the simpler applications of graphing. So your x-axis, or your explanatory variable, will be represented by time. The variable, the letter that we use for time, is t. And the y-axis, which is our response variable, going back to the terminology we used in the data analysis unit, is d, and that's distance. So time along the x-axis, and distance along the y. Distance time graphs, well, basically it's used to measure how far an object is from a certain point after a certain amount of time. So d equals 0, that's our initial position, that's what we're measuring from. Now the gradient is really interesting here and tells us just as much as the x and y value do. The gradient is the speed the object is moving. So distance divided by time is of course this is our y value, our rise over our run. Distance over time, for example, might be kilometers over hours, kilometers per hour. And just a gentle reminder, when you are creating one of these graphs, label your axes, please. Have a go at worked example number 1. I haven't followed my own advice here. This is the time in seconds, and the y-axis is the distance in meters. So have a go at this example, and then come on back here again once you're finished. This is the distance in meters. So have a go at this example, and then come on back again once you are finished. The other type of question we're going to look at is a half-life question. Often used in science, it measures the amount of time it takes for an amount of something or a value of some sort of a substance to be cut in half. So if originally I have 10 kilograms of some object or substance, how long does it take until I have 5 kilograms cut in half? And then again down to 2.5 kilograms, and so on. In this case, the y-axis will often be given as a percentage of the original. So our y-intercept will be 100. So I start off with 100% of the substance, and then I'll be looking at how long until I have 50% left, or 25%, or 10%, or whatever it might be. And the x-axis represents time. Very common example of half-life is talking about any radioactive material. They have a half-life, which means that they decay over time, and if you have 10 grams of this material, if you just leave it and don't touch it, which is a radioactive material you probably shouldn't be touching anyways, at some point you'll only have 5 grams left, and then it'll get cut in half again, and again, and again, as you get less and less and less. Apologies to the video game fans. We're talking about a different half-life here. Have a go at worked example number 2. looking at the amount of a radioactive element that you've got and how it decays over time. Success criteria. Can you do it? Can you interpret nonlinear graphs used to model situations using two variables? So what I'd like you to try and do is look in the newspaper or search online for a news story that contains a graph and try and understand what it means. So it could be in the finance section, could be in the sports section, it could be somewhere else looking at global politics or anything like that, and see if you can understand what story the graph is trying to tell you.